Okay, for number 5, again, I'm looking at this picture. I'm glad they provided it to me and looking at what the relationship is, all right? So I want to talk about the angles for this problem over here. And looking at it, I'm going to say it starts at theta equals 0. Then what happens over here, again, it's whipping around like this here. That would be theta equals pi over 2, right? Does that make sense? Well, at 0, what would I get? 3 minus 3, which is 0. That makes sense there. I see the origin. The radius is 0. At pi over 2, I'd get, 3 minus 0, which is 3. I see that. And then it's going to keep moving along. And over here, this is where I'm going to get the number pi. All right, that's where theta is pi. Does that make sense to me? Well, looking at it, the cosine of pi is minus 1, so I'd get 3 plus 3, which is 6. Certainly makes sense. It keeps whipping around. Over here, what's the angle over here going to be? Theta equals 3 pi over 2. And what's 3 pi over 2? Well, for cosine, that's 0, and I just get 3, so it makes sense there too. And then it keeps going around, and then it'll eventually repeat itself. And it comes back to itself when theta equals 2 pi, and then it keeps repeating itself. So I think I kind of understand the graph, and what I want to do is write down the integration now. All right, so let's put that down. And the area of this thing is going to be 1/2. I'll put the d theta over here. We're starting at 0, stopping at 2 pi. It's going to fill that thing up over there. And then I take this r and I square it. So it's 3 minus 3 cosine theta quantity squared, right? What do I do now? I got to simplify that, and that can be tough, but let me put this down. A equals, kind of looking at it, definitely get a 2. I'm going to factor the 3 out. That would give me, 9, because I'm squaring it. 0 to 2 pi. And if I did that, I get 1 minus cosine theta squared, which is 1 minus 2 cosine theta plus cosine squared theta d theta. All right? So I'm going to say, for the most part, it looks familiar. It looks like I've done these before. All right, let's put this down again. Area, I got 9/2, 0 to 2 pi. And I got 1 minus cosine of theta. I'm going to reduce the degree of the cosine by using those, the double angle formulas. And it's going to be cosine 2 theta plus 1 over 2 d theta. All right, I got to keep moving through that. And let's keep going. I'm going to start adding things together that I can. So I see a 1 and I see a 1/2, which is 3/2. I just did that. I just did that. Minus cosine theta. And then let's see, plus cosine 2 theta d theta. I think I can pretty much integrate this as it stands. And let me write that down for you. I'm going to get 3 over 2 theta minus, let's see, I'll be careful here. Oh, you know what? I made a mistake somewhere. I copied wrong, and I just noticed it. This should be a 2. So it's going to be 2. And what differentiates a cosine? Sine, right? And then, let's see, what differentiates cosine? That's going to be sine again. But when I differentiate, I get a 2, so I got to get rid of that, put a 2 on the bottom. And limits of integration are going to go from 0 to 2 pi. All right, I got some work to do. And, I always say one step at a time. 9/2. I'm plugging in 2 pi first. So I get 3 times 2 pi over 2, which is going to be the 2's cancel. So I get 3 pi. And then what do you get? The sine of 2 pi is 0. I'm not going to write that down. Let's see, the sine of 4 pi is 0. I'm not going to write that down. So I'm done with this. And then minus 9/2. And I'm going to plug in the 0. Well, every term gives me 0 then. So I think I have my answer. We'll check the key in a moment. That's going to be 27 pi over 2. And we're done. Next question. Thank you.